This is section 8.3, and in this section we are going to be talking about graphing functions in the form f of x equals ax squared plus bx plus c. So in the first section we graphed f of x equals ax squared. The second section we tacked on that constant at the end, and in this third section we're going to have a middle term which ultimately will allow our graph to translate left or right. So the first section, your vertex was always 0, 0. The second section, you can move up or down, and now this one we can move left or right, or a translation left or right. Okay, so the first thing we're going to talk about is this axis of symmetry equation. And eventually we can prove how to derive this equation. It's going to require something called completing the square. Here's a quick proof of it. I'm not going to go through that right now. That's something we're going to learn in a future section. So for that, at this moment, I want you to actually memorize this equation, x equals negative b over 2a. That is how we're going to find the axis of symmetry. Remember, the axis of symmetry is the line that cuts that parabola into two equal pieces. So it goes right down the middle of the parabola, and therefore it always goes right through that vertex. The vertex will always fall on the axis of symmetry line. So I put a note down here. It says we start by finding the axis of symmetry, this vertical line, in order to know which x values make sense to plug into an xy table. And what I mean by that is, let's say you were trying to graph a parabola and the axis of symmetry is way over here. So let's say you're over at, I don't know, 16. X equals 16 is your axis of symmetry equation. It wouldn't make sense to plug in 1, 2, 3, 0. It wouldn't make sense to plug in those numbers because let's say your parabola is right here. Well, if this is your parabola and you go and plug in a 1, you're going to get out some huge number way up here. Let me get rid of that. You're going to get out some massive number, and it's not going to help you find what this graph really looks like. So if I know that my axis of symmetry is at x equals 16, well then it would make sense to plug in x equals 17 or 15 or 18 or 14, and then it's much easier to see what that parabola starts to look like. So we find the axis of symmetry first to know that middle of that parabola, and then we plug in x coordinates around that axis of symmetry value. All right, get rid of that. So again, please memorize this equation, x equals negative b over 2a. That is the axis of symmetry equation. To find a y-intercept of the graph, just another easy point to find, we still plug in 0 for x. So x is 0 for a y-intercept. X is 0. If you plug in 0 for x, you get out c, because if I plug in a 0 here and a 0 there, anything times 0 is 0, anything times 0 is still 0. We're left with c. So 0c is the y-intercept. In the previous section, when we're looking at equations in this form, 0c was the vertex, which was also the y-intercept. But now because we can translate left or right, that y-intercept is no longer necessarily the vertex. So 0c is the y-intercept. The next piece here, two new vocab terms, the maximum or minimum. The maximum is the highest height of a parabola if the parabola opens down. So you have a maximum height. So it'd be the y-coordinate of the vertex. Let's say if the y-coordinate of the vertex, that is your maximum. If the parabola opens upwards, then you no longer have a maximum, you have a minimum. So a minimum, if the parabola opens upwards, is the y-coordinate of the vertex still. So they're both the y-coordinate of the vertex. It's just which way is the parabola opening. So if it opens down, it's like a mountaintop, you have a maximum peak. If it opens up like a valley, then you have a minimum height. All right, so let's try an example here. It says find the axis of symmetry. Again, the axis of symmetry equation right here is x equals negative b over 2a. So we're going to use that axis of symmetry equation. So axis of symmetry equation, x equals negative b over 2a. And we just have to know what is a and what is b. Well, a right here, remember these are all in the form y equals ax squared plus bx plus c. They're all in the form y equals ax squared plus bx plus c. So this is y equals a is 3, ax squared plus bx, so here's b is negative 6, and just while I'm at it, I'll also show you c. C would be right here, plus c, so c is 1. So your a, b, and c values are your coefficients. All right, so x equals negative b over 2a is the axis of symmetry. So negative b, negative 6, since b is negative 6, negative b is negative 6, so negative 6 over 2 times a is 3, 2 times 3. Now we simplify, the negative cancels out, so we get positive 6 over 2 times 3 is 6. So the axis of symmetry is x equals 1. And I threw this in some graphing software here just to show you. Um, this is my original equation. The red graph is the equation. And I just graphed x equals to 1 to show you that that is the line that cuts it right in half. And then there's the vertex on there, 1, negative 2. So the axis of symmetry cuts the parabola right in the middle. All right, so example number 2, oh, sorry, example number 1 continued. It says find the vertex. Well, I just showed you the vertex on the graph here. It's 1, negative 2, so I know that's what we should get, but let's figure this out. How can I actually find 1, negative 2 algebraically? Well, again, that vertex always has to lie on the axis of symmetry. If the axis of symmetry cuts the parabola directly in half, and the vertex is the highest or lowest point of this U-shaped graph, called a parabola, then the x-coordinate of the vertex is always the same as the axis of symmetry value. So if you get x equals 1 for the axis of symmetry, the x-coordinate of the vertex is 1. So how do we find this negative 2? If x is 1, how do we get that y-coordinate? Well, if x is 1, I make x 1, and now I can solve for y. That's how we do that. I put a couple of notes on here. I said the vertex is always on the axis of symmetry, as I verbally just said. And then we know the axis of symmetry is x equals 1 from the last slide. So we just found that on here. We got x equals 1. So if I plug in my axis of symmetry value, which is a 1, and I solve for y, so 3 times 1 squared is just 3. 6 times 1 is 6. 3 minus 6 is negative 3. Plus 1 is negative 2. Well, is that what I should have gotten out? Yep, 1, negative 2. So my vertex, the vertex is 1, negative 2. When I plug in 1 for x, I get out negative 2 for y. And there it is. There's my vertex. All right, still example 1 continued. Does the function have a maximum or minimum? And then find the value of the max or the min. Well, this 3, a is greater than 0. A equals 3. So a is greater than 0. So the parabola opens up. So this graph looks like this. A very, very rough sketch of it. It opens upwards. If that's the case, if it opens up, it's going to have a lowest point, and the height of this point is going to be the minimum. So how do we find the value of the minimum? Well, we already know that the vertex from the last slide is 1, negative 2. This is from the last slide. From previous slide. So we know the vertex is 1, negative 2, so the height of the vertex is the minimum. So this guy right here, the minimum, is negative 2. So the graph has a minimum, and the minimum is negative 2. So it all depends on this a value. If a is positive, the graph opens up, so it has a minimum. If a is negative, the graph would open down, and then it would have a maximum. But the max or min value is always the y-coordinate of the vertex. All right, still example 1 continued. Find the y-intercept. The y-intercept, if you go back in the slides, it's 0c. But to find a y-intercept, we always plug in 0 for x. So we plug in 0 for x. Okay, I'm going to make that note right here. Plug in 0 for x. We've been doing that since middle school. Plug in 0 for x. And solve for y. All right, so y equals 3 times 0 squared minus 6 times 0 plus 1. If you know it's 0c, you don't have to actually plug in 0 because these are always going to cancel out. You just go, oh, well, it's 0, 1. So we get y equals 1. We can show it algebraically, but ultimately it will always be 0c, so it will always be 0, whatever this number is out here. In this case, it is 0, 1. All right, so example 1 still continued here. This is the last part of example 1. This one says, graph the function and then find its domain and range. Well, we've got all of this information that we found in the previous slides, and we're going to use that to graph this function. So the axis of symmetry is x equals 1. So at x equals 1, that is the equation to a vertical line. This is x equals 1. I'm going to draw a dashed line because that's not actually part of my parabola. It's going to help me graph the parabola. The vertex is at 1, negative 2. 1, negative 2. Put a point there. So my vertex at 1, negative 2. My y-intercept is 0, 1, so I can put a point at 0, 1. The minimum is negative 2. Well, that doesn't really help me graph anymore because I know the vertex already is at 1, negative 2. So, using the information we have so far, I know it's a parabola because it has an x squared term. I have my axis of symmetry and my vertex and my y-intercept graph. I can get one more point based on this information alone. I know it's a parabola, which means it's a U-shaped graph, and I know that it's symmetric about the axis of symmetry. So if I have this point at 0, 1, that's 1 unit away from my axis of symmetry. If it's symmetric about this line, I should have another point the same distance away on the other side of it right here. So you can use that information. If you have a point on one side, you just mirror it across the axis of symmetry and you can graph your other point. All right, so I've got 3 points. I really want at least 5 points to graph a parabola just so I can really know what it looks like, so I don't just kind of guess at how wide or narrow it is. So what I'm going to do for those couple other points here, I'm going to plug in. I'm going to go 2 units to the right of that axis of symmetry. So I'm going to plug in 1, 2, 3 for x. I'm going to plug in 3 for x, and I'm going to see what I get out for y. Oops, wrong button there. There we go. All right, so I'm going to make a little x, y table. I'm going to plug in 3 for x and see what I get out for y. So plug in 3. I'll show the work over here. I'm plugging in 3. Y equals 3 times 3 squared minus 6 times 3 plus 1. And I get 3 squared is 9 times 3 is 27. Minus 6 times 3 is 18 plus 1. 27 minus 18 is 9. And 9 plus 1 is 10. So I get out 10. So 3, 10, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At the very top of my graph here, 3, 10. And I can use that same idea. If I'm 2 units away from my axis of symmetry on this side, I should also have a point that's 2 units away on the other side because it's the axis of symmetry. It's symmetrical about that line. So there we go. I can erase my little markings here. That's not actually part of my graph. It's just to make a point. All right. And now I'm going to draw my parabola. And again, these are U-shaped graphs. Try to make them U-shaped graphs. So it is a parabola. And hopefully you're not doing this with a mouse because it's not easy. All right, there we go. And this is the graph of y equals, I should have used function notation so I didn't write the whole thing out here. Y equals 3x squared minus 6x. What am I doing? I'm using a computer. Silly me. There we go. Beautiful. All right, and there is one more piece of this problem. It says then find its domain and range. So domain and range are never going to go away, and they're back. All right, so domain and range of this graph. The domain is the set of inputs or x-coordinates. The x-coordinates. The range is the set of y-coordinates, all possible outputs. So on this one, the x-coordinates, well, I have an x-coordinate of 1. I've got every number between 1 and 2, because this has an x-coordinate of 2. I have every number between 2 and 3. This keeps going right and left forever. So it's going to have every single imaginable x-coordinate. So this domain is the set of all real numbers. Remember that double R represents the set of all real numbers. The range, the set of all possible outputs or y-coordinates. The lowest height here is negative 2. This minimum tells me that the lowest height is negative 2. It goes up from there, and it goes up from there forever. So the range is the set of y such that y is greater than or equal to negative 2, because negative 2 is my lowest height in my graph. So all the other points have heights above negative 2. They're all greater than negative 2. All right, so there we go. That problem has everything. So on your, if I were to have you in class and I were to give you a test, you would see a couple of problems like this where you have to find all of these different pieces and then also graph. I'm probably not going to have you do everything at once on your online quizzes. That's just a little bit hard to set up, but you will have to do each piece individually at some point. All right, example 2, graph the function, find its domain and range. So this is the last example of this section. So graph the function. Again, in order to know, I don't want to go right to an f of x table, an input-output table, because I'd just be guessing in the dark. I wouldn't know what to plug in for x, because I don't know where that axis of symmetry is. So the first thing you should always do on graphing a parabola, on graphing a quadratic equation, is find the axis of symmetry. So I'm going to start there. I'm going to start by finding the axis of symmetry. And again, we do that using the equation x equals negative b over 2a. And this one, we don't have a c coordinate, so just throw that out there. The c coordinate is 0. I shouldn't say coordinate. The c value is 0. The constant is 0. So you can always put a plus 0. A in this example is negative 2. B in this example, I could put plus bx. So plus bx, b is negative 4. And again, while I'm at it, c is 0. So the coefficients, the numbers before the variables, those are the a, b, and c values. So axis of symmetry is x equals negative b, negative 4 over 2a. 2a is negative 2, so 2 times negative 2. So my axis of symmetry is negative, negative cancels out. I get 4 over negative 4, which is negative 1. So x equals negative 1. That is the axis of symmetry. I'm going to put my dashed line on my graph to help me visualize where the axis of symmetry is. Okay, this is x equals negative 1. There we go. All right, so I know if I'm going to go and make an input-output table, I know that my parabola is symmetric about this line. So I'm going to plug in, I'm going to start by plugging in negative 1, and then I'll plug in numbers that are just a little bit bigger than negative 1 or a little bit smaller than negative 1. So I could plug in 0, 1, 2, or maybe negative 2, negative 3, negative 4. But I always want to start by finding the axis of symmetry so I know what x coordinates are going to really help me find that shape of that parabola. All right, so let's go ahead and plug in some numbers. If I plug in negative 1, let's just do some mental math. Negative 1 squared is 1, times negative 2 is negative 2. If I plug in negative 1 here, I get positive 4. So I have negative 2 plus 4, which is positive 2. Just follow the order of operations. So if you, I suppose I can show it for one of these. If you didn't follow me, just verbally saying that, if I plug in negative 1 for x, so f of negative 1, I get out negative 2 times negative 1 squared minus 4 times negative 1. I just plugged in negative 1 anywhere I saw an x. And then I simplify, so negative 2, this becomes just a positive 1. This becomes a positive 4, and negative 2 plus 4 is 2. So that's how I got out that 2. All right, if I plug in 0, they both cancel and I get out a 0. If I plug in a 1, I get negative 2 minus 4 is negative 6. If I plug in a 2, I'd get a 4, negative 8 minus 8. Negative 8 minus 8 is negative 16. So I'm just going to go ahead and graph those. So negative 1, negative 2, negative 1, positive 2, 0, 0, 1, negative 6, and then 2, negative 16 is way down there. So this parabola looks like it's opening down. Should it open down? Well, a is negative, so yeah, that makes sense. It should open down. So that's one thing you can look at to make sense of, is my graph correct? All right, I don't actually have to plug in these other numbers because I know it's symmetric about the axis of symmetry. So if I have a point here that's 1 unit away from the axis of symmetry, well, I better have one that's 1 unit away on the other side. If I have one that's 2 units away on this side, I better have one that's 2 units away on the other side. And that's how it forms that U shape. So you could plug in -2 and -3 and see what you get out, but we know we should get these points out. All right, so you can go ahead and graph my parabola. Okay, and this is the graph of f of x. And it says find the domain and the range. So for the domain, again, with these parabolas, they go left and right forever, and there's no breaks in the graph, so it's the set of all reals. For the range, its highest height is at +2, and it goes down from there. So I'd say the set of, we're dealing with f of x, so the set of f of x such that f of x is less than or equal to 2. So instead of using y, we're using function notation, so I should represent this with function notation. All right, so there we go. That is all this problem asks of us. So for your assignment, it is a book assignment, pages 436 to 437, numbers 3 through 16 and 27, and I do want to go through some of these with you right now. So let's start with number 3. So let me just go ahead and open up your assignment here. So number 3. In number 3, it says we need to find the vertex, the axis of symmetry, and the y-intercept. Well, we're just given a graph here. So the vertex, we can visually see it's the lowest point of this graph, or the highest point if it opens down, and it's at 2, -1. So the vertex is at 2, -1. The axis of symmetry always cuts the parabola right in half and always goes right through the vertex, so it's always going to have the same value right here. So the axis of symmetry, I'm going to use AOS for axis of symmetry, is at x equals 2. We'll always have that same value as the x-coordinate of the vertex. And then it says the y-intercept, we need to find the y-intercept. So visually it crosses the y-axis at 0, 1, so the y-intercept is 0, 1. So that's how you're doing on those problems. You just visually look where is the information that they're asking for. On the next set of questions, so I'm going to skip the rest of these. You have to do the other 3. It says find the axis of symmetry and the vertex. So let's go through, I'll go through one of the ones with the fractions because I know how much students love fractions. Let's go through number 11. So number 11, it says find the axis of symmetry. Well, for the axis of symmetry, we have the equation x equals -b/2a. So x equals -b, -4 over 2a. A in this case is 2/5. 2/5. All right, so we just need to simplify this. So x equals, the negatives cancel, we get 4 over 2 times 2/5. You're really multiplying 2 over 1 times 2/5. Multiply straight across, we get 4/5. 4/5. And 4 divided by 4/5 is the same thing as 4 times the reciprocal of 5/4. The actual reasoning behind that is because I can multiply by 5/4 over 5/4. And these 5's cancel and those 4's cancel. So you're just multiplying by that big old 1. Anything over itself is 1. 5/4 divided by 5/4 is 1. So the 4's here are going to end up canceling, and I get x equals 5. So that is my axis of symmetry. If you need to use a calculator, that's okay. So 4 divided by 4/5, you could use a calculator. Just be careful. If you do 4 divided by, you're going to want to put a parentheses. 4 divided by parentheses 4/5. If you don't, some calculators can do it correctly and some cannot. Let me just see if this one gets it right. 4 divided by 4/5. And yeah, it doesn't give me the right answer because it's doing 4 divided by 4 first and then divided by 5. So you need to do 4 divided by parentheses 4 fifths, and then it will give you the right answer. All right, so that's number 11, axis of symmetry. Then that was part A. For part B, it says we need to find the vertex. Well, the vertex it always lies on the axis of symmetry. So we know the x-coordinate already is 5 something. We know the x-coordinate's 5, but what's the y-coordinate? Well, how do I find this? I just plug in the x-coordinate for x in my equation. So I need to plug in I need to plug in 5 for x. F of 5 equals 2 fifths times 5 squared minus 4 times 5 plus 14. So I'm just using my equation here. I'm plugging in 5 anywhere I see an x. Follow the order of operations to simplify. So I get 2 fifths times 25. 25 divided by 5 is 5 times 2 is 10. Minus 4 times 5 is 20. Plus 14. 10 minus 20 is negative 10. Plus 14. So I end up getting a 4. F of 5 is 4, so 5, 4 is my vertex. You just plug in the axis of symmetry value for x and you solve for y. All right, so that was number 11. Let's see, 13 through 16 says graph and then describe the domain and range. Since I did a couple of those in the examples, I'm going to skip over these for now. Remember though, find the axis of symmetry first to help you know what values of x to plug in right around the axis of symmetry. And then you have to do number 27. I like this problem a lot. So this one says the function shown represents the height of fireworks t seconds after it's launched. So you're starting at ground level, height of 0. You're launching those fireworks up, and they get to a highest point. It says the firework explodes at its highest point. So at the highest point here, at the maximum, that's where the firework goes off. So part A says, when does the firework explode? So you are trying to see, okay, if I'm at the highest point at the maximum, what is the value? This isn't using an x, it's using t. So what's the value of t at that maximum? So I'm gonna let you think about that for a little bit. This is an odd problem, but I'm really looking for work when you do this one. Please don't just give me an answer. Don't just look in the back of the book. I need to see the work for this problem to give you credit. All right, so there you have it. I will eventually post the answers to these assignments, to this assignment, but for now, this will be due on Thursday by 11:59 p.m. All right, thanks.